All right, so we're going to continue with transformations by looking at reflections. So what we've looked at prior to this is translations, which takes a function's graph and shifts it horizontally and or vertically. We've looked at scale, how a transformation could involve a vertical stretch or shrink, and also a horizontal stretch or shrink. And now we're going to look at reflections, reflecting the graph or a function's graph over the x-axis and over the y-axis. So I want us to take the example that we were looking at before, and I'm going to pull my calculator in here, and I'm going to type in the original square root function that we dealt with. So we had the square root of 9 minus x squared. And so just as a reminder, this is what the graph looked like. Okay? So now I want us to graph the opposite of the square root of 9 minus x squared. So I will go back to y equals. I will go down to y2. There's my negative or opposite. I will go get my square root and 9 minus x squared. And so now when I graph, you can see where the blue graph, which was the original, and the red graph, which the negative out front took the blue graph and reflected it across the x-axis. Okay, so here we have when the negative is out front, it's reflected, the graph is reflected across the x-axis. Okay, so now let's take a look at the square root of 9 minus the opposite of x squared. So now what's happening is we have the square root of 9 minus, now what's being, now we're looking at the opposite of x, so I'll have to open parentheses and type in my negative, not subtraction, but negative x, close the parentheses, and square it. Okay, so now when we graph, I will press graph, and look what happens. I know it's hard to see, but if you paid attention to the graph, you could see a little bit of blue being graphed as well. Well, what happens is this graph, the blue graph is directly underneath the red graph. So you may be saying, okay, well, this graph is the same as the original mom and daddy. And yes and no. This particular graph is actually a reflection of the mom and daddy graph that we worked with, and it is a reflection across the y-axis. If we take a simple y equals square root of x, okay, let's take the y equals the square root of x. I'll go into y equals, I'll clear out what I have, and going back to y equals, the square root of x looks like this. If we go back to y equals and we type in the square root of negative x, or the opposite of x, watch what happens. Notice that the blue graph has been reflected across the y-axis. So whenever you have the x that is negative, the graph will be reflected across the y-axis. So this is a reflection across the y-axis. And the reason why this other graph was so hard to see is because, or let me rephrase it, the reason why this graph is easier to see is because the original graph only had a portion of the graph, or the graph was only on the positive side of the y-axis. So you could actually physically see the graph being reflected across the y-axis. Okay? All right, so I'm going to take and put that aside for just a second. Now let's take a look at the parent function again, y equals f of x, or y equals x squared actually. And I want us to describe the reflection for this function. Well, this is still a quadratic. We know that there's going to be some translations of horizontal and vertical shifts, but all I'm interested in is the reflection. The 4, the fact that it's negative, will mean that there will be a reflection, the graph will be reflected across the x-axis. Excuse me. Okay, now look at the next example. We have f of x equals 2 times 4 minus x squared minus 3. Well, you could look at this and say, okay, my x is negative, so we know that there's going to be a reflection across the y-axis. Now, you might not like the way this looks, and if you wanted to put this or rewrite this in the form y equals a, which is 2, times the absolute value of x, which is negative x, plus h squared minus 3. You might like that a little, well, that's not h, it's 4, sorry. So that should be a 4. So we could have it as negative x plus h squared minus 3. Okay, so now let's talk about the parent function, the absolute value of x. So just as a reminder, what does that graph look like? The absolute value of x looks like this. And so what I want us to do is I want us to write the equation of this function, this absolute value of x function, that would have a vertical shift of 1 up and reflected about the x-axis. Okay, well, if we have a vertical shift up 1, that means k is positive 1. And if the graph needs to be reflected about the x-axis, that means a has to be less than 0 or negative. So writing the equation, f of x equals, a has to be negative, so I'll put my negative out front of the absolute value. So I have negative, or the opposite of the absolute value of x, plus 1. And that would take care of that. All right, then we have the same function, but this time I want us to write the equation of f of x that has a horizontal shift of left 2 to the left. That means that my equation inside the parentheses will have x plus 2. So this x plus 2 will shift the graph left. I want this to be reflected about the y-axis. So I need a negative out front. And we also want a vertical shrink by a factor of 5. Now, this don't be tricked into making a mistake here. Keyword here is shrink. So we know that the y values must get smaller. So we're going to have a 1/5 on the outside. So f of x equals negative 1/5 the absolute value of x plus 2. And is that all the things that I needed? Yes. So there's your equation. Okay, so now let's look at taking what we know and seeing, sketching the graph of a function that has some transformations to it. Okay, we have the equation f of x equals negative 2 times the square root of x plus 1 minus 3. The parent function for this would be f of x equals the square root of x, and we should know that the graph of the square root of x looks like this. Okay, so here we have a point at 0, 0. We have a point for the square root of x would be 1, 1, and then we have a point 4, 2. Okay, so I'm just kind of getting an idea and just remembering what the parent function looks like. So now if I want to sketch the graph of this, then let's think about what we could do. So if I want to, I may just make a little table. I don't know. Sometimes you can actually do this without creating a table. You know that each of these points will be reflected across the x-axis. So if I were to begin the process without creating a table, I would still have a point at 0, 0. When I reflect the graph across the x-axis, my x value stays 1, but my y value becomes -1. So my point would be right there. And then I have a point at 4, 2 here. 1, 2, 3, 4, 1, 2. My graph would be reflected across the x-axis, and it would look like this. Okay. All right, so now, let's see. I need to, all of these values should be, all of my y values here should be multiplied by 2, because there's going to be a vertical stretch of 2. So what does that mean? That means that this point is still at 0, 0, but this point, 1, -2, 1, -1 will be at 1, -2. And this point at 1, 2, 3, 4, -2 will be at 1, 2, 3, 4, over 4, down 4. Okay, so that's taking care of the reflection and the scale. Now let's take care of translating all of these points left 1 and down 3. So left 1, this point goes left 1 and down 3. I'll get a new color. Left 1, down 3. This point goes left 1 and down 3. This point, hang on a minute, which one am I loop? I lied. I think I used the wrong one here. This point goes left 1, down 3. That point should be right here. I lied. And then this point, left 1, down 3. And so my graph looks like this. So I took care of the reflection first, so R. Then I took care of the scale, and then I took care of the translation. Okay? Okay. Now let's take a look at our next example. Our next example is going to be an absolute value function. So let's remember what the parent function for the absolute value function looks like. We have a parent function that looks like this. And so, which is f of x equals the absolute value of x. So we have points 1, 1. We have a point, 2, 2, and so on. Okay, but let's take a look at the equation. Our equation is going to, I think it would be better, especially when we start thinking about the translations. I think it would be best if we actually take a look at this equation as this. The 2x minus 4, if I were to factor out a 2, then I'm looking at 2 times x minus 2. And then I have this plus 2. Oops, sorry. And I think my dogs are going to bark here in just a minute. Maybe, maybe not. So let's see if I can get through this without my dogs barking. Okay, so let's think about what I need to happen here. Do I have a reflection? I do not. My outside, my A value is positive, and my X value is also positive. So I do not have a reflection. So let's talk about a scale. If you look at this equation, what is the absolute value of 2? Well, the absolute value of 2 is 2. So I could actually bring that out front and make that 2/3. So 2/3 times the absolute value of x minus 2 plus 2. Okay? So let's see. We want to take each of these values and the y values, because 2/3 is on the outside, the 2/3, each of the y values is going to be multiplied by 2/3. So my 0, 0 point stays at 0, 0. My point at 1, 1 goes over 1, but goes up to 2/3. And then I have, let's see what else I have. Let's say then I have 2, 2. I go over 2 and up 4/3, because 2 times the 2/3 is 4/3. So 4/3 is just a little bit up past 1. And then if I wanted to do 3, 3, like here's the point 3, 3, I would go over 3. 3 times 2/3 is going to be 2. So this piece, I've got this piece going on. And if I, because of the symmetry, I would have a point here, a point here, a point here, and then a point here. So, so I've taken care of the scale. Now I can take care of shifting, or the translations of this graph, all the points being shifted 2 to the right and 2 up. So if I go from this point here and go over 2 and up 2, my point is right there. If I take the point here that I go over 2 and then I go up 2, my point is here. And this point, I'm going to go over 2 and up. That wasn't right. So go over 2 and up 2. I still have my points a little off, but you have your shifts, and that's going to look this way. So sometimes it might be helpful if you were to create a table of values for x and then f of x, and then an ordered pair, so to speak, and that would help you as well. So transformations include reflections, scales, and translations. So let's take a look at all of this one more time. Let me put that aside and pull this up. And here's what I want us to do. Notice that this particular set of examples says, given the parent function y equals f of x. Notice I don't have a specific function. I want us to write the equation of f of x that has or have the given transformations. So, all right, so we're going to be working with y equals f of x. Okay, so y equals f of x. I need a horizontal shift of 3 to the right. So that means I have to have an x minus 3. I need a plus 2. And I need a vertical stretch of 5. All right, so I'm going to start with y equals f of x. Okay, I need a vertical stretch of 5. So I'm going to have 5 times f of x, but I also have a shift of 3 to the right. So I'm going to have f of x minus 3. I'm also going to have a vertical shift of 2 down, which I said that wrong. That should be a minus 2. So I have minus 2. So what I've got here is this tells me that I'm going to, my function f, whatever it is is going to be shifted to the right 3 and down 2, and the y values, or the 5 tells us that we will have a vertical stretch of a factor of 5. Okay, so this is just writing the equations in a general form to represent any function. All right, so y equals f of x is what we're starting with. And I want the equation f of x to have a horizontal shift of 2 to the left, a vertical shift of 1 up, and a vertical shrink of 1/2. So f of shifting 2 to the left would be an x plus 2. So it's the function where x plus 2 will have a vertical shift of 1 up, and we have a vertical shrink of 1/2. Okay? And again, we're just working with, remember, functions that are in the form of y equals a times f of bx minus h plus k. All right, and then this one, we do not have a horizontal shift. We have a vertical shift of 1 down, and we have a vertical shrink of 1/6. So here's my original, y equals f of x. Vertical shrink of 1/6, no horizontal shift, but a vertical shift of 1 down. So that's going to be y equals 1/6 f of x minus 1. There is no horizontal shift, so there's nothing in there with x. There's a vertical shift of 1 down, so we have our minus 1 on the outside, and then the vertical shrink of 1/6, so it's 1/6 on the outside. Okay, so now we have example 6, and we have, let's see, we have starting again with y equals f of x. Horizontal shift 7 to the left, so that's x plus 7. No vertical shift, a vertical stretch of 2, and a horizontal stretch of 8. And here's where we have to be careful. We also have a reflection about the y-axis. Okay, so I'm going to have y equals, I have a vertical stretch of 2 and a reflection about the y-axis. Oh no, that's not the x-axis. So I have 2 times for my vertical stretch. So 2 times f of, okay, so I have here's where we got to be careful. We have a horizontal stretch of 8 by a factor of 8, which means, remember what we have to do with that. I'm going to have f of 1/8 x. I have a horizontal shift of 7 to the left, so it's 1/8 of x plus 7. And what else do I have? I have a reflection about the y-axis. So I can make my negative 1/8. The negative will make this graph reflect across the y-axis. And then do I have a vertical shift? And that is no. So I don't really have to put a plus 0 out there, but I need to go back, and I want to go back and make sure of all this. So horizontal shift of 7 to the left. So I have 8 x plus 7 in parentheses. So that's taken care of. I don't have a vertical shift. That's that plus 0. I have a vertical stretch of 2, which that's on the outside of this f function. So I have that one. My horizontal stretch of 8 has to be 1/8 because it has to be the reciprocal. And then I have a reflection about the y-axis. So my negative goes with the 1/8. I want to talk real quick before we go to the next one is be careful about writing this expression as negative 1/8 x plus or even minus, I'll even say, I'll say it plus 7/8. No, that's not what I was trying to do. Be careful about this. Writing this as simply f of negative 1/8 x plus 7. We have to be really careful here because this is not correct. The negative 1/8 x would be okay, but when we go to talk about a horizontal shift, the HS, the horizontal shift, if I actually take this whole expression, negative 1/8 x plus 7, and set it equal to 0, when I solve this for x, I get negative 1/8 x equals negative 7. And if I multiply and get x by itself, that's actually going to be x equals 56. That is not the horizontal shift. And so we have to be careful about how we write this. I know this is really nasty and messy, but ultimately, this turns out to be y equals 2 times f of negative 1/8 times x plus 7, and that's it. Okay? There's no k value. All right, so you kind of have to pay attention, and you have to focus, and you have to just kind of try to work through this and think through it. All right, let's do the last couple. I want to have a horizontal shift of 4 to the right, 1 down, no vertical stretch, horizontal stretch of, there's our 8 again, and then reflection about the x-axis. So y equals f of x. So my equation then will be y equals, I need to shift the graph 4 to the right, 1 down, no vertical, but a horizontal stretch of 8. So here's what we got. f of 1/8 times x minus 4 minus 1, that needs to all be closed. My 1/8 is going to horizontally stretch the graph by a factor of 8. I need to x minus 4, 1 down, and then I need to address the reflection about the x-axis. So now I just have to put my negative out front. Okay? All right. And then finally, lastly, let's see. We'll do no vertical stretch. Now this is called copying and pasting without changing anything really. But that's okay. Y equals f of x. And I want to shift my graph 4 to the right and 1 down. I have a horizontal shrink of 1/4. Okay, and I want the reflection to be about the y-axis. So y equals f of, if I need to shrink this graph by a factor of 1/4, it's going to be 4x, or 4 times x minus 4, because of the 4, but it has to be reflected across the y-axis. So my 4 here needs to be negative. And do I have a shift down? Yes. So I'm going to clean this up and look at it. So I have y equals 4 times, not 4 times, but I have f of negative 4 times x minus 4 minus 1. So I have a horizontal shift of 4 to the right. I have a vertical shift of 1 down. I have a horizontal shrink of 1/4, which means I have to multiply the x by 4. And for there to be a reflection about the y-axis, I have to have the coefficient of x to be negative. And so there you have it. So once you start really thinking about putting all this together, it can get a little confusing. But just pay close attention and really think about what you're asked to do. And hopefully it'll work out okay once you've practiced this a little bit.